Yes.
Like, I need to get the stuff down for my partner to write it into the box.
The data? You probably need to go sit by your partner and get a copy down. You can go sit by your partner and get a copy down. I'm going on record right now and saying that the Cleveland Guardians will win tonight 7-1. The date is, I don't know what the date is. October 17th, 2024. I'm going to game 3. Never forget this. If that happens, that is now.
Wait, this 9 weeks hasn't even been 9 weeks.
Has it? Yeah, it has.
No, because my birthday wasn't even 2 months ago.
For teachers, it's felt like 12 weeks because we had those work days at the beginning of the year. So
My birthday was the first day of school, and it's not October 21st, which would be 2 months.
I don't know.
And 2 months is only 8 weeks. This has been 7 weeks.
I don't know. I don't ask questions. I just know the first quarter's over. That's all I know. Okay. Here's what you need to do. Watch my screen. You are going to highlight starting at time and temperature all the way down to where your data stops. Not the observations, just the numbers. So once again, you're going to highlight time temperature, not the title, just time temperature, down to where your data stops. So you can see what I have highlighted. Do we have that highlighted? Yeah. Yes? Yeah. I'll do it one more time. I'm going to highlight time temperature, go down to where my data stops. Are we highlighted? Yay?
Yeah.
Then I'm going to go to insert. I'm going to go to insert up here. I'm going to go to insert. I'm going to go to insert. And I'm going to choose chart. Check that out. It literally did the whole thing for you. Do I have temperature versus time for my title? Yes, I do. Do I have temperature in degrees Celsius on my y-axis? Yes, I do. Do I have time in minutes on my x-axis? Yes. Yes, I do. You are now going to drag this down under here where it belongs. So you will see a spot where it says put your graph here. Drag your graph down here onto your spot. Got it? Everyone have the graph done? That was easy. Now let's scroll up and talk about these questions. Should we just do them together?
Yeah.
Okay, let's just do them together. Okay. So here we go. Why does temperature stay the same during a phase change? We talked about this on our 2-column notes. Why does temperature stay the same? Anybody?
Oh, because of our evolution level.
The what level?
Wait, why does that?
That's not what I'm asking.
Oh, never mind.
Temperature stays the same because the same amount of energy I'm putting in is the same amount of energy it takes to do what? Remember? What am I breaking?
I know it.
My particles are like this, then they're like this. Bonds. So, the same amount of energy being put in is the same amount of energy needed to break the bonds. So we're looking for something like that. Would you agree we were consistently putting more heat into our beaker? Yeah, from the hot plate, right? What was happening at the same point when it was boiling? What was escaping? Gas, right? So that gas, you break those bonds, that's when the temperature stayed constant during our phase change. That's from 2-column notes, right? You guys remember talking about that? C. Now, look at my graph. If I look at my graph, did my temperature stay the same during my phase change when it was boiling? Yeah, mine was like 99. Down here, it stayed mostly the same when it was melting, right at 0. Okay. Water boils at 100 degrees Celsius normally. What was the highest temperature you recorded? 99. What else? 99.6. So we're going to say
That's because of the elevation.
the highest temperature recorded was, fill in your number from your lab. So what was your highest temperature? Fill in your number from your lab.
How do you do like Celsius?
You just type in the words like degrees Celsius. So for me, I could say it was, for mine, my data was 99. So I'm going to say was 99 degrees Celsius. Why is this the highest temperature recorded? We're basically asking, why didn't it boil at 100? Kaylee,
We're not,
we are not at sea level. So we're going to say this happened because Ohio is above sea level. Specifically Worcester, Ohio. If we were in Miami, water would boil at exactly 100 degrees Celsius.
Wait, so that means since we're only 1,000 feet above the ground, and Denver is like
5,280.
so practically 5,000, that means it would boil at 95 degrees.
Water boils at 83 degrees Celsius in Denver, Colorado. So if you are making mac and cheese in Colorado, is it going to take longer or shorter to cook? Longer. The water will boil more quickly, but the water's boiling at a much lower temperature. So your water will boil more quickly, but it's going to boil at a colder temperature. Why? There's less atmosphere pushing down, easier for it to escape. Doesn't take as much energy. So in Denver, what do they have to use to cook? Pressure cookers. So you put more pressure on it, it's harder for those bonds to escape. So in Denver, you're getting your temperature back up to 100. Here, anybody here ever use an Instant Pot? An Instant Pot is a fancy pressure cooker. It gets your pressure higher than 1 atmosphere, and it makes your food cook above 100. Makes it cook more quickly. That's how a pressure cooker works. It's just science. Just science. Moving on. What was the freezing point of water for your lab? So I'm looking down here. Where'd your water freeze? Mine freezed at 0. What'd you guys have? Did yours freeze at 0?
Yeah.
Okay. Mine froze at 0 degrees Celsius. And if my water freezes at 0 degrees Celsius, guess what temperature it also melts at? 0. The same. It freezes and melts, froze and melted at the same temperature. Do you have both of those filled out?
Yes.
How do you do the chart?
The chart?
Yeah.
So you have to go to time temperature, highlight all of your data, just to where your data stopped. And then I went to insert chart. You have to highlight time and temperature or it will not put in the labels for you. You good, Zach?
And then you go to
Insert and then chart once it's highlighted.
Yep.
Good? Yes? Xander, is he good? Do you have a title on your graph? You should have a title. You should have a y-axis that says temperature degrees Celsius. Your x should say time in minutes.
Yeah.
Yes? If you feel good about it, turn it in. We're done. Nah, we're not doing those. Nah.
Now we can do hangman's for the rest of the month.
No. We're going to do something else. So turn that in on Google. Anybody need help?
No.
I will be able to help you in a second. So if you still need help, I will come help you in a second. You need help? Okay, 1 second. What? Need help? Okay. Once yours is, if you don't need help and you're done, close your Chromebook so I can tell who needs help. Close your Chromebook so I know that you don't need help. So we now have 2 choices for the rest of the period. Choice number 1, we can watch Bill Nye. Choice number 2, we can watch Bill Nye and fill out a worksheet while we're doing it. Okay, I figured you'd choose choice 1. So, for choosing choice 1, make sure your Chromebook is not open, you are not distracted. While this Bill Nye is going, I'm going to go around and help anybody else that needs to finish up their lab. Okay? So do not open your Chromebook. I'm going to be around to help people finish stuff up. Yes?
I don't know how to help him get the highlight one for him.
You just have to click, drag, and then insert chart.
Mr. Howard, I would like to do option B.
What? You want to fill out the paper?
Yeah, how about this?
All right. I'm going to be coming around and helping people that still need help on their lab. So, please, no talking. You can hit the lights. All you have to do is watch this. Super easy. I'm going to come and help you, Andre. I'll get to you. Here we go.
You feel it? It's building. You're pushing in all directions at once.
Need help or are you good? Okay, so, oh, you're good. Yeah, you're good. We're good. It's good. Okay, then you're gonna go to Insertar, Gráfico. Good. Yeah, then drag it down. Put it, just drag that to the, so click. Good. Did you answer the questions? Yep. You're good. Joel, you guys good?
Pressure
Almost.
or water or anything. Pressure is what makes rockets go.
Can you guys scoot your desk over that way a little bit? Coming up. Burp, 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 burp.
Air come into our lungs.
Okay, so
Now take a look at this. It's our water
I'm gonna
pressure
highlight.
breaker of science.
That's what you have to
The
do.
kind of bricks you might make a sidewalk out of.
then
And
inserts
over
our
there is a bucket of colored water. It's
Graphico.
connected to a hose, and the hose
Done.
is connected to this.
Then
big
drag that
plastic
down.
cylinder. Now, right now, the pressure in the cylinder, the pressure in the hose, the pressure in the bucket are all about the same. But if I raise the bucket way up, and the pressure down here will be higher because the weight of the water is pushing down. It's the same way you feel pressure on your ears when you dive to the bottom
Stay
of the
awake.
swimming pool. The weight of the water makes pressure, but the pressure in here will push up on this big plastic disc. The plastic disc has so much area that it will create a lot of force. And that force will go up this metal rod and into these bricks.
Almost there. Are you good?
Let's hoist the bucket.
Still on a pass.
Now, pressure is going down the hose, into the bucket, pushing on the brakes.